Welcome back to the deep dive. We're here again digging through, all the docs, the roadmaps, the commits, this time looking at what's next, the big future stuff,
Yeah,
and trying to boil it all down to what you actually need to know to stay ahead.
exactly. Today, it's all about .NET 10. And this isn't just another update. This is the new LTS, the long-term support release. So it's got support for 3 years. If you're building anything serious, anything production grade, .NET 10 is basically setting the standard for performance and security for quite a while.
Right. And the sheer amount of stuff in here, it covers everything from the core guts of the runtime to new C-sharp syntax and, well, some really heavy-duty security updates. Our job today is to cut through that noise, give you the actionable bits, where are the real speed gains, what makes you more productive, and what keeps your apps safe long-term.
Yeah, the big themes seem to be integration and like hardening things up. .NET 10 makes the foundation faster, smarter, but it's also kind of blurring the lines between coding and deploying, especially with containers. And then there's this huge cryptographic armor they're adding. It's quite something.
Okay, let's get into it, starting with the engine, the runtime itself. When they talk performance leaps in .NET 10, what does that really mean?
Yeah,
I see things like JIT improvements, but, where will I actually feel it?
that's a fair question. It's not just a tiny percentage boost here and there. These are pretty targeted architectural changes. You'll see the biggest impact in places with lots of I/O, lots of network traffic, like microservices, things like better JIT inlining and method devirtualization. They specifically cut down overhead in common library calls, abstract interfaces. So if you've got high traffic API endpoints, you're actually shaving off latency, maybe even double-digit percentages under load.
So smarter about how we actually build things now, not just raw speed.
Precisely. They've also improved stack allocations and something called loop inversion, which basically means the runtime is smart enough to pull code out of a loop if it doesn't need to run every single time. Saves CPU cycles, less redundant work.
Okay, that's the software side, getting smarter. But it's hitting the hardware better too, right?
It is. .NET 10 adds specific support for AVX 10.2. Now, you might think, okay, I build web apps, who cares? And yeah, mostly it helps high-performance computing, AI, ML workloads, anything doing heavy math, vector stuff. For those areas, it means getting much closer to C++ performance. And for everyone using native AOT, ahead-of-time compilation. Big improvements there, too. Leaner binaries, faster startup, almost instant.
Okay, the engine's tuned up. Let's talk about the garage then, the SDK, developer tools. Beyond speed, what about just making life easier day to day? Any friction removed?
Efficiency seems to be the goal. They standardize the CLI command order. It's a small thing, but it's one less thing to remember when you switch projects. And finally, the CLI generates native tab completion scripts for shells like Bash, PowerShell, Zesh. Honestly, that alone, it's going to save so many hours debugging typos in .NET publish commands.
Oh yeah, tab completion for the CLI, that's huge. Definitely a lifesaver.
Huh?
Okay, now the deployment side. The container stuff feels like a really big shift, almost philosophical.
It is massive. Console apps can now natively build container images directly. No need for external Docker files, no extra tools installed on the machine. You literally just set a property in your project file, build it, and boom, you've got a container image ready to go. You can even set the image format explicitly now, too.
Wow, that really changes the whole deployment dependency chain, doesn't it? It pulls that tooling layer right back into the developer's hands. It makes it truly build and ship from a single command.
Exactly right. It internalizes container building. Besides containers, there are other neat tooling things too, like platform-specific tool support using this generalized any runtime identifier, more compatibility.
And I saw something about one-shot execution for running tools quickly without installing them everywhere.
Yeah, .NET Tool Exec. So you can run a tool just based on a local manifest or a package reference without needing a global install. Great for quick validation scripts or keeping your CI/CD environment clean and isolated. It keeps you inside the .NET world more productive.
All right, let's shift to the code itself. Runtime's faster, but the language is getting cleaner too. C# 14. What's the biggest, daily annoyance it fixes for developers?
I'd say the biggest one is dealing with backing fields for properties. You know how you start with a simple bioproperty, like publican, IBK, set, Philambi, and then later you need validation or logging in the setter. You had to manually add a private field, rewrite the get and set. It was clunky.
Yeah, that refactoring dance was always awkward.
Totally. Now, with field-backed properties, you use the field keyword right inside the accessor, get field, set field with a value, but you can add logic around it. It accesses the compiler's hidden field directly, just makes that whole process way smoother, keeps the code cleaner.
That is a really nice simplification. Okay, What about the name of enhancement? Supporting unbound generics like list. Why is that a big deal? Is it mostly for library folks doing reflection?
It definitely helps library authors a lot.
Hmm.
Before, name of needed the full type, like name of listens. Now, name of list just gives you list. Super useful for logging, reflection scenarios, generating docs where you just care about the type name itself, not the specific arguments. Less error-prone string manipulation.
Makes sense. And for the performance crowd, better support for implicit conversions with SPANT and read-only SPANT. SPANs are already key for speed and memory, so making them easier to work with just helps everywhere.
Yep, efficiency and clarity again. Another nice touch is using parameter modifiers like ref, in, out, and lambdas without needing the full type definition. Keeps those little lambda functions shorter, cleaner.
And we're getting more structure, too, with these new extension blocks.
Oh yeah, extension blocks are important for organizing code. They let you define static extension methods and also static and instance extension properties. It's a much cleaner way to group extension logic, especially in big projects. Makes things easier to find and maintain when you're adding functionality to existing types.
And finally, less repetitive math. Support for user-defined compound assignments like plus and fles and the increment-decrement operators plus, plus list.
Right. If you've ever made a custom number type, like for money or fixed point math, you had to implement plus and then also implement plus separately. This just cuts down that boilerplate. Makes your custom types feel more like built-in C# types.
Okay, so C# 14 is giving us some great syntax, sugar, and structure. But what about the other languages in the family, F# and Visual Basic? Are they keeping pace? What's the focus there?
For FSHOB, it's mainly about enabling new features, simplifying some syntax, improving type inference. The main thing to know right now is that these new F# features aren't default yet. You have to add LangVersion preview LangVersion to your project file to turn them on until the final release.
Got it. A Visual Basic. Still going strong.
Yeah, VB is focused on making sure it can use all the modern runtime features effectively. Like, the compiler now understands the unmanaged generic constraint, which helps with low-level interop and memory safety. And crucially, it now pays attention to the overload resolution priority attribute. This means if there are multiple ways to call a method, it will prefer the faster, span-based versions that performance folks love. So VB is definitely staying relevant, especially where performance matters.
Okay, moving us back to the libraries. This feels like where the future-proofing really kicks in. We have to talk security, data integrity. Before the really sci-fi quantum stuff, what about basic data handling like JSON?
The JSON updates are subtle, but actually pretty important for security. They added new options, specifically to disallow duplicate properties when reading JSON, and generally stricter settings you can opt into.
Oh, stopping duplicate properties? That's key. Prevents attackers from sending weird JSON where the server might get confused about which value to use. Good guardrail.
Absolutely. And on the performance side, they added pipe reader support for JSON, which helps when you're streaming really large JSON documents efficiently. Networking gets a new, simpler WebSocket Stream API, and TLS 1.3 support finally lands for macOS clients. But yeah, the really big headline, like you said, is the post-quantum cryptography expansion.
Right. This feels like we're getting protection against a future threat just baked in. Sounds super technical, though. Lots of acronyms. CNG, MLDSA. What exactly is .NET 10 doing here? Why should the average dev care?
So this is all about defending against the theoretical risk that future quantum computers could break today's encryption, like RSA. The support comes via Windows CNG, which stands for Cryptography API Next Generation. And the main algorithm they've added support for is called MLDSA.
MLDSA.
Yep, it's a lattice-based algorithm. The important part is it's designed to be resistant to attacks from quantum computers. They've provided simpler APIs to use it. They also added hash MLDSA, and this is really interesting, composite MLDSA support.
Composite. What does that mean here?
Composite means they're cleverly combining a traditional, well-understood algorithm like AES with one of these new post-quantum ones, like MLDSA. It's a hybrid approach. It gives you a safety net during this transition. If, hypothetically, some flaw was found in the new quantum-resistant algorithm, you still have the protection of the classic one. It's a really smart, careful way to start moving towards quantum-safe applications. Oh, and they also added AES key wrap with padding support, which helps secure key exchange.
That's a huge step. Very forward-thinking. Okay, frameworks now. What are the practical improvements people will see in their running apps? Let's start with ASP.NET Core.
ASP.NET Core sees some nice performance boosts and big identity updates. Blazor WebAssembly gets preloading, so your Blazor apps should feel faster on initial load. There's also automatic memory pool eviction, better form validation, but the headline grabber for security is native passkey support built into identity.
Passkeys, that's the current gold standard for fighting phishing, right?
Exactly. So if you use ASP.NET Core Identity, you basically get this super secure, phishing-resistant login method almost for free. No need to wrestle with complex third-party stuff. Huge for modern security needs.
Okay, database side. Entity Framework Core 10. What's the big news there?
The standout feature is definitely named Query Filters. This tackles a complexity headache. Before, managing different data access rules could get really messy. Now, you can define multiple name filters on an entity type. Maybe one for multi-tenancy, one for soft delete, and then choose which ones to apply or ignore in specific queries. Much cleaner data policy control. Plus, the usual improvements to LANQ translation, performance tweaks, and better Azure Cosmos DB support.
And MAUI for mobile development. What's new?
MAUI gets some nice user-facing improvements. The media picker can now select multiple files at once, and it supports compressing images before uploading them. Saves bandwidth. Also, WebView request interception arrives, giving you more power to customize how embedded web views behave in your app. And of course, keeping up with the platform support for Android API levels 35 and 36.
Great. And quickly, what about the classic desktop apps? WPF and Windows Forms aren't forgotten.
Not at all. Windows Forms gets some clipboard improvements and more ported UI type editors from the old .NET framework for smoother migration and compatibility. WPF sees performance work, which is always good, and updates to align better with the Fluent design style for a more modern Windows look and feel.
Phew. Okay, that was a lot. We went from deep runtime optimizations all the way to quantum-resistant encryption. Let's try and summarize the three absolute biggest themes here.
Okay, number one. Raw speed and efficiency. Those JIT and runtime tweets are aimed right at modern architectures, like microservices, for real latency wins. Number two, developer experience. Big boost from C# 14's simplifying common coding patterns, reducing boilerplate, and the SDK stuff, especially the native container building, really streamlines workflows. And number three, security. That massive investment in post-quantum crypto is huge. It's about ensuring applications built today are secure against threats years down the line.
Yeah, it feels like a very complete package. You've got the stricter controls, like stopping duplicate JSON props, coupled with this really advanced crypto. It's not just about speed, it's about building solid, trustworthy apps.
Exactly. Hardening the whole thing while making it easier and more elegant to actually write the code.
So, wrapping up, here's something for you to think about. That new SDK feature, allowing console apps to natively create container images. It merges development and deployment right into one command. Think about how that fundamentally changes the responsibility and maybe the power resting with you, the developer. When deployment becomes that seamless, that integrated into your daily tools, what new security considerations pop up? How do your own local security practices need to adapt to match that power? Something to chew on as you explore .NET 10.
It's a really interesting shift in the developer's role, for sure.
Thanks for joining us for this deep dive into .NET 10. We'll see you next time.